All right, welcome to another session of RTX Compare. Today it's also going to be MLX Compare because we are comparing Qwen 3. This is the 14 billion parameter model, and we're testing it on two devices. One being this Windows 11 Pro with a 5070 Ti with 16 gigabytes of RAM, and this MacBook Pro with an M5 Pro chip and 48 gigs of RAM. And the major differences between the two are that the Mac Pro is about a third in terms of memory bandwidth at 273, and I think this is 896. So three times the memory bandwidth goes to the Windows device. However, on the memory side, this has 48 gigs of RAM and this has 16. So therefore, we're talking about a three times difference in overall memory or RAM or available RAM. The one to the left is CUDA because it's using an NVIDIA stack, and the one to the right is using MLX. And CUDA is very well known for being the industry standard in compute. So the expectations, because this is a small bottle, is that everything's going to be much faster on the left side of your screen. But enough talk, let's give it a look. Tell me all about Tyrannosaurus Rex. Tyrannosaurus misspelled. This is a thinking model, so it's available for us to see what the thought process is. So let's give that a look. And very quickly, you can see how much faster decode is when you have a much faster memory bandwidth or much higher memory bandwidth. This is still thinking on the right. It's already finished thinking on the left. And I'd say, is it three times the speed? Probably. I'd say probably three times the speed. Now, these results are kind of subjective because I'm seeing that the Mac is actually showing a lot more information. Remember, this is the same model, so I don't know why it's actually doing that. All the queries are exactly the same, and not the queries, all the prompts are exactly the same. But yeah, there's seems to be a lot more information showing up on the Mac. Let's open up a new chat. Let's paste a different query here. The query is, tell me about elephants in as much detail as you can. And I'm going to turn off the code interpreter just in case. Let's give it a look again. Interesting, this thinking came first compared to the NVIDIA. However, it completed faster when it finally launched up. That's weird. It's actually looking at querying knowledge bases. That's odd. But either way, it's already spilling out the information, and as you can see, the speed is significantly faster spelling out the data or spelling out the information onto the screen. It's already completed, and the Mac is still going. And it's already completed the follow-up text. In terms of the amount of information, the NVIDIA shows a lot, but doesn't seem as much as the Mac. So definitely two different styles, although I'm surprised because these are exactly the same. This is exactly the same model. So the results should be somewhat similar. Let's do some tooling. Let's turn the code interpreter on first. And let's load up our 18K automotive file. It's this one right here. This is a 398 by 9 data set of automotive information in miles per gallon. And let's find a query we can use. This one right here. That's odd. It's still going for ingestion. Sometimes this happens. It gets stuck. It's only 18K, should be fast, but let's load it up again. But the prompts are exactly the same. Let's change the model here to make sure. I'm surprised it's taking this long to actually ingest the file, but it's done. Okay, yeah, we're calling Python. Tooling is enabled. And let's see what it does. Now, while this is running, I am going to say, when you have a 14 billion parameter model and it's a 16 gigabyte card, the amount of KB cache is not going to be as high as what you would have here because this is 48. So 3 times the cache, and what it usually results in is it's unable to properly open up the file. We're seeing a lot of thinking for both models. It's significantly faster, yes, on the NVIDIA side, but I'm more concerned about the accuracy and the quality of the results than the speed of it. Okay, so again, this is 398 by 9 file, and the Mac is only able to open up 3 rows and 8 columns. That is incorrect. And this is opening up 15 and 9 columns, which is also incorrect. So they're both really incorrect. The correct answer is 398 by 9. 398 by 9. So they're both incorrect. One's slower and incorrect, and the other one's faster and correct. So not great. But yeah, I want to try this again. A little. It's not a common thing where they're both incorrect. I'll make sure it's not a glitch or anything. I'm not going to have it do all the fun stuff. I'm just going to have it only just use Python to find the total number of rows and columns for now. So it's not having extra tasks. Let's try that again. So thinking went first here on the Mac. It hasn't begun thinking yet. I actually think that the DGX or the NVIDIA is in trouble. I think it's approaching the max of its KB cache, and it's spilling into memory. But look at the sheer speed of it. And unfortunately, same thing, right? 15 by 8 is what it's able to find. And here, 3 by 8. So yeah, not great. But at least here, it is showing me the code for actually trying to find the shape in Python. And this also did the shape. So what happens if I actually click run? We've seen it where when it runs out of memory, it just guesses. But here we're actually calling the pyodide. And it's unable to find the file. Look at that. It's unable to find the file here. Same thing. I think it's having an issue with accessing the file. So definitely we're having problems with tool assessment. But for what it's worth, you know, the objective today was to really just see the token speed. And let's go back to the previous chat earlier and see if we can ask it more questions on the elephants. And then let's ask it, tell me more. How much would I like to learn about? See, this is an elephant thread, and now it's asking me weird questions about features, tools, and workflows. At least here, it's showing me more information about elephants. Yeah, I think that the RTX is starting to get wonky. Now it's starting to, it's getting confused. It's trying to look at tools now using knowledge bases. And it's starting to provide not so great information. I mean, this seems correct, but look at the Mac Go. So I think what we're seeing here is when you have a lot of KV cache, because you had a lot more memory, regardless of the speed of it, it's actually trying to get as much information to the user as much as possible. Whereas here, it's just giving us whatever it can because it's about maxed out. I'm confused because we do have 48 gigs of onboard RAM. It can actually spill over, but it looks like it's choosing not to do that. So I think for small queries or the first initial queries, it's fine. About cats. But when you start to run out of memory, it starts to get, well, it's more favored towards the Mac side of things. Remember, this now is a new chat. And we can clearly see that when it's a new chat, you get a lot of faster thinking on the left side. And the right side is maintained to be slow, but again, the amount of information that it spills out is a lot, right? Behavior, communication, physical traits, behavior, communication, no physical traits, but social structure. So either way, I think having this setup with the same model kind of shows us the output differences when you have more memory and when you have a higher memory bandwidth. And it's just one of those kind of things where this is why we do what we do. We try and we compare results with different configurations. Anyways, tokens, I didn't get a chance to measure it as much. We can take a look at the info here. Gosh, I'm not even able to press it. There we go. It's in terms of info tokens, we have all of that. I would say that we're talking, I don't know, 40 tokens per second compared to 15. Sounds about right. So yeah, Qwen 3 14B on an RTX 5070 against the MacBook M5 Pro. Thanks a lot for watching.